Assalamualaikum and hi guys. So today we will continue for the next chapter, which is our last chapter, chapter 5 for the Fourier series. Fourier series is a way to represent a periodic function as the sum of sine and cosine function. So what is the periodic function? So periodic function is a function that repeat a pattern at some period. So this is the notation for the periodic function. Fx plus 2L. So 2L is the period of the graph. So example, we have this graph. So the solid line here is the original graph, whereby the period is equal to the 2 pi. So it starts from 0 until 2 pi. So after 2 pi until 4 pi, so this is the repeated pattern of the original graph. So as we can see here, the period of the original graph is 2 pi. The repeated pattern is also 2 pi. So this one is pi. This one is also pi. So pi plus pi will become 2 pi. So the same pattern on the left hand side from 0 to the negative 2 pi. So the repeated pattern is also 2 pi. So let's refer for the next example. Fx is equal to x the power of 2 from negative pi to pi. So the periodic function if f x plus 2 pi. So 2L is equal to 2 pi and L is equal to pi. So some of the question will ask you to determine what is the value of L. So this is how to determine the value of L. Or another method is from the highest limit here, which is L is equal to pi. When we plot the graph from negative pi to pi, from negative pi to pi, so this is the graph for the x square. Okay, and then from this original graph, the period is 2L is equal to 2 pi, whereby from negative pi to pi, the period is equal to 2 pi. The repeated pattern is from pi to 3 pi. So this one is also 2 pi. So the same pattern will be repeated on the left hand side, which is from negative pi to the negative 3 pi. So the period is also 2L, whereby 2L is equal to 2 pi. Okay, so for this chapter, there are 3 things that you have to learn. The first one is how to determine the types of the function, whether the types of the function is odd, even, or neither function. The second one, how to determine the graph, whether the graph is odd, even, or neither function. Okay, so based on the given function, you have to know how to sketch the graph, and then from the graph you have to determine the types of the graph. The third one, how to solve the Fourier series expansion. So now let us continue for the first subtopic, how to determine the type of the function, whether the function is odd, even function, or neither function. So you will be given the function in terms of polynomial or trigonometric function in terms of sine and cos. For example A, determine whether fx is equal to x square is an odd function, even function, or neither function. So before you want to determine the types of the function, so let's refer to this note. So you will have 3 types of the function: even function, odd function, or neither function. So for the even function, if we get back the original function of the fx, so fx is considered as an even function. So for the odd function, if we change all the positive and negative signs of the odd function in the fx, means that the function of fx is an odd function. For the neither function, if we only change the certain sign of the positive or negative in the fx, so fx is considered as a neither function. So now refer for this example, fx is equal to x the power of 2. So the first step, substitute x become negative x. So f negative x will become negative x the power of 2. And then you have to simplify. negative the power of 2 will become positive. Positive x the power of 2. So this is our f negative x. So now we want to compare f negative x with fx. So when we compare f negative x is equal to x the power of 2, compare with the original function fx is equal to x square, you get back the original function, right? Because this one is x square, original is also x square. So this is what I mean by, for the even function, if we get back the original function of the fx, so this one is an even function. So since f negative x is equal to x square and your fx is equal to x square, means that we get back our original function. So the conclusion is fx is equal to f negative x. Therefore, fx is an even function. Okay, now let us proceed for the next example. Fx is equal to x the power of 3. So the first step, we need to substitute x become negative x. So fx will become f negative x is equal to x the power of 3 will become negative x the power of 3. So always remember to write negative x in the bracket. So now simplify. So negative the power of 3 will become negative. So f negative x will become negative x the power of 3. So now compare with the fx. So when we compare our negative x the power of 3 with the x the power of 3 here, this one is not the same thing. Because this one you have negative, but original there is no negative of x the power of 3. So from the notes here, if we change positive or negative sign of all function in the fx, so fx is an odd function. So for this one, from positive x cube, we change into negative x cube. So the conclusion is fx is equal to negative fx. So therefore, fx is an odd function. For next example, fx is equal to x the power of 3 minus 2x. So the first step, substitute x become negative x. So f negative x will become x the power of 3 negative x in the bracket power of 3 minus 2x minus 2 in the bracket negative x. So now simplify. Negative x the power of 3, negative the power of 3 will become negative x the power of 3. Negative 2 multiply negative x, negative negative will become positive 2x. So this is f negative x. So now we want to compare f negative x, which is negative x the power of 3 plus 2x with the x the power of 3 minus 2x. So as we can see here, original is positive x cube and then it's changed become negative x cube. Original, this one is negative 2x and then it's changed become positive 2x. So means that we change all the positive and negative sign of the original function. Original positive is become negative. Original negative is become positive. So therefore, this one is an odd function. So the conclusion is fx is an odd function. So you can directly write your answer like this. So for next example, example D, fx is equal to x squared plus 2x. So the first step, you have to substitute x become negative x. So f negative x is equal to x the power of 2, negative x in the bracket the power of 2 plus 2 multiply negative x. And then we need to simplify. F negative x is equal to negative the power of 2 will become positive x square. Positive 2 multiply with the negative x. Positive with the negative will become negative 2x. So now compare with the original. Original x square, and then your f negative x still x square. Original 2x, and then f negative x is negative 2x. So means that this one is not change all the positive and negative sign. If we change all the positive and negative sign of the original function, that one is an odd function. But for this one, it's not change all the sign, because it's only changed from positive 2x become negative 2x. So if we only change certain positive or negative sign in the original of fx, so that one is considered as a neither function. So therefore, for this example, this one is a neither function. So fx is a neither function. Why neither function? Because it only change certain positive and negative sign. Why certain of sign? Because this one x square, it's remain the same thing x square. But for the positive 2x, it change, it become negative 2x. So that's why it's only change a certain sign of original fx. So therefore, fx is a neither function. For the next example, fx is equal to cos of x. This one in terms of trigonometric function, in terms of cos. So fx is equal to cos x. So the same step, substitute x become negative x. So f negative x is equal to cos in the bracket negative x. So now how to simplify cos of the negative x? You cannot simply bring the negative to the front, because in terms of trigonometric function, this one is not the same thing as the polynomial function. So this is only for your understanding. Let's say we substitute x equal to 180 and x is equal to negative 180 into the f negative x. So our f negative x is cos negative x. F negative x is equal to cos of negative x. So when we substitute x become 180 into the negative x here, x is equal to 180. So therefore, f negative 180 is equal to cos of negative 180 is equal to negative 1. When x is equal to negative 180, we substitute to the negative x here. So x will become positive 180. So therefore, cos of 180 is equal to negative 1. So as you can see here, if you substitute x equal to the positive 180 or x is equal to negative 180, the value is the same thing, which is negative 1 and also negative 1. So means that if you substitute positive or negative value, you will get the same answer. If we get the same answer, the cos of negative x here, we can ignore the negative. So means that if we ignore the negative, so f negative x will become cos of x. So from here, we compare with the original function. So when we compare f negative x equal to the cos x, compare with the fx is equal to the cos x, this one is the same thing, whereby we get back the original function. So the conclusion is fx is an even function. So notes for here, function of cos x is always even. For next example, fx is equal to sine of x. So the same step, substitute x become negative x. So this one will become sine of negative x. So from here, we need to consider whether sine of negative x, we can ignore or cannot ignore the negative x here. For the cos, we can ignore the negative sign because you will have the same answer. So the same thing, this one is only for your You don't have to show this calculation. Let's say we substitute x become 90 degree and x is equal to negative 19 into f negative x is equal to sine of negative x. So let's say your x is equal to 90. F negative 19 is equal to sine of negative 19. So by using the calculator, the answer will become negative 1. So when we substitute x is equal to negative 19, f negative x, whereby x is equal to negative, this one will become positive of 19. So f positive 19 is equal to sine of positive 19. So by using the calculator, sine of the positive 19 is equal to positive of 1. So what we can conclude here, if we substitute positive of 90, you will have negative 1. If you substitute negative of 90, your answer will become of 1. We don't get same answer. Therefore, we cannot ignore the negative sign. For the cos before this, we can ignore the negative of sine. So the negative here we can ignore for the cos, but for sine we cannot ignore the negative of sine here. So when we cannot ignore the negative of sine, so we need to bring the negative of sine to the front of trigonometric function of sine here. So bring the negative to the front. So therefore f negative x will become negative sine of x. So now compare your f negative x with the fx. So original, there is no negative at the front, but for the f negative x, we have negative sign at the front. So when we change from positive become negative, so this one is an odd function. So the conclusion is fx is an odd function. Okay, now let us continue for the next example. We have complete example A, B, C, D, E, F. So now before we continue for the example G, so let us continue for the example H first. Fx is equal to 2 sin x multiplied with the cos 4x. So if you can see the difference, example A, B is only a single function polynomial. Example C and D, this one in terms of minus operation and plus operation. For example E and F, this one in terms of trigonometric function. But for the example H here, the trigonometric function is in terms of multiplication. So the operation can be in terms of plus minus operation or multiplication or a single function. So fx is equal to 2 sin x multiplied with the cos 4x. So the same step, you have to substitute x become negative x. So fx will become f negative x is equal to 2 sin x. So position of x will become negative x, 2 sin negative x multiply with the cos 4x. So this one will become cos. In the bracket, we have 4 multiply with x. So 4 multiply x will become 4 multiply negative x. So 4 negative x is equal to negative 4x. So in this bracket will become negative 4x. Negative 4x. So now simplify. So now we will apply the step that you have learned before this. For the sin negative x, we will bring the negative to the front of sign. For the cos of negative x, we will ignore the negative. So now we have 2 sin negative x. Negative here bring to the front of 2 because we have a constant 2 at the front here. So bring negative to the front. And for the cos negative 4x, the negative here we will ignore. So therefore f negative x is equal to negative 2 sin x multiply with the cos 4x. So when we ignore the negative, there is no more negative for the 4x. So now compare the f negative x with the fx here. So when we want to compare the function in terms of multiplication, you only have to compare the function at the front here. So the function at the behind here, we can only just ignore. Because the function at the behind here is always become the same thing because we already simplify that one. So compare 2 sin x with the negative 2 sin x. Original is positive and then it's changed become negative. So if we change the positive become negative sign, this one is an odd function. So the conclusion is fx is an odd function. So now let us continue for the g. Fx is equal to x square multiply sine square the power of 2. So you have sine square here. So sine square the power of 2, this one is also can be written as sine 2x the whole thing the power of 2. So always remember to change. If you have sine with the power here or cos with the power here, make it in the big bracket power at the outside. Rewrite back, fx is equal to x square multiply sine 2x multiply the whole thing here with the power of 2. So now substitute x become negative x. F negative x is equal to x square will become negative x the power of 2 big bracket sine of 2x sine of the bracket here 2x. When we substitute x become negative x, this one will become 2 multiply negative x. 2 multiply negative x will become negative 2x. So negative 2x will be substituted in this bracket. Negative 2x. Close the bracket, the whole thing the power of 2. So now we need to simplify. Simplify from the front. Negative x the power of 2. Negative power of 2 will become positive x square. So in this bracket power of 2. If we have sine negative x, the negative here we bring to the front of sine. Unless the front here you have a constant of 2 or constant of 3, then bring the negative sign to the front of the constant. But for now, you have sine of negative 2x. So this negative bring to the front of sine because you have big bracket here. So bring negative to the front of sine. So negative sine 2x the power of 2. So this negative power of 2 will become positive. X square sine 2x the whole thing power of 2. So this is our f negative x. So now we want to compare f negative x with the original of fx, whereby this one is the fx that we have written back in terms of power of 2 at the outside. So when we compare, as I mentioned before this, if your function in terms of multiplication, we only compare the function at the front. So compare the x square, original is positive x square, and then your f negative x is also positive x square. So means that this one is an equal function. So therefore the conclusion is fx is an even function. For example I, fx is equal to 2x plus 3 multiply with the sine 4x. The first step, substitute x become negative x. So if you have polynomial multiply with the trigonometric function, you don't have to expand, okay? So no need to expand. You just direct substitute x become negative x. So f negative x is equal to 2x, this one make it in bracket, 2 multiply negative x plus with 3. So close the bracket, multiply with the sine 4x. So 4 multiply negative x, this one will become negative 4x. So negative 4x substitute to the bracket of the sine negative 4x. And then you have to simplify. Simplify for the first bracket here. 2 multiplied with the negative x will become negative 2x plus with 3. Close the bracket. Sin negative 4x. Okay. For the sine function, negative here you have to bring to the front of sine. So for here, 2 multiply negative x plus 3 multiply with the sine of negative 4x. So you have something at the front here. If you bring the negative to the front of sine, at the end, you have to bring the negative here to the front, because the negative is for the whole thing. So now, directly bring the negative to the front of the bracket. So this negative, I will bring to the front of the big bracket. So will become negative at the front here. Sine of 4x. So negative multiply negative 2x plus 3, you have to simplify negative to be multiplied inside. Negative multiply negative will become positive 2x. Negative multiply positive 3 will become negative 3. Multiply with the sine 4x. So now compare f negative x with the original function of fx. So as I mentioned before this, if you have function multiply function, so function at the behind here, you don't have to compare because it always become the same thing. So now compare function at the front 2x plus 3 with the 2x minus 3. Original positive 2x, and then when you substitute negative x, this one is remain as 2x. Original is positive 3, and then it's changed become negative 3. So means that it only change position positive 3 become negative 3. But positive sign at the front here, it remain the same. So this one is a neither function because it only change a certain of sign. So the conclusion is fx is a neither function. Okay, now let us continue for the next example. Fx is equal to exponent x. So now the function is in terms of exponential function. So fx is equal to exponent the power of x. So the first step, substitute x become negative x. So f negative x is equal to e negative x. So now we need to simplify for the negative here. For the sign, we can bring the negative to the front. For the cos, we ignore the negative. But for the exponent here, what should we do? So let's say we substitute x is equal to 1, 2, and 3, which is in terms of positive value. And x is equal to negative 1, negative 2, and negative 3 into the f negative x is equal to exponent negative x. So if x is equal to 1, e negative 1 is equal to 0.37. If x is equal to 2, e negative 2 is equal to 0.14. So if x is equal to 3, exponent negative 3 is equal to 0.05. So this one we substitute x is equal to positive value to the exponent negative x. So now let us continue. X is equal to negative 1, x is equal to negative 2, x is equal to negative 3 into the position of exponent negative x. So exponent negative x, x is equal to negative 1. So this one will become e the power of 1. E the power of 1 is equal to 2.72. X is equal to negative 2. So therefore exponent of 2 is equal to 7.39. X is equal to negative 3. Exponent 3 is equal to 20.09. So if you can see, the value for the exponent in terms of positive and negative value is not the same thing, whereby we can conclude that exponent x is not the same thing as the exponent negative x. So the conclusion here, fx is a neither function. But let's say if you have fx is equal to exponent x the power of 2. Okay, so the difference is this one exponent x power 1, this one exponent x power 2. When we substitute negative x, e negative x power of 2 will become e x the power of 2. So when we compare with the original fx, you will have the same thing with the original fx. So means that this one is an even function. So therefore fx is an even function. So for the exponential function, if your exponent in terms of power odd, the function is a neither function. If your exponential in terms of power even, your fx is an even function. So exponential cannot become odd function. It only can become a neither function or an even function. So the calculation that I show here is only for next example, fx is equal to exponent negative 2x multiply with the x square plus 4. So first step, substitute x become negative x. So exponent negative 2x, this one will become exponent negative 2 multiply negative x. Multiply x square, make it in bracket x square plus with 4. So now you have to simplify. So simplify from the front, negative 2 multiply negative x, this one will become positive 2x. Negative x the power of 2, negative the power of 2 will become positive x square, make it in bracket plus with 4. So now you need to compare your f negative x with your original function of fx. So as I mentioned before this, if you have function multiply function, you don't have to compare the function at the behind here because this one is always the same thing. So compare exponent negative 2x with the exponent 2x. Exponent negative 2x is not the same thing as the exponent 2x. So therefore fx is a neither function. For the last example, fx is equal to exponent x the power of 2 multiply with the cos 2x. So the first step, substitute x become negative x. So exponent x the power of 2, make it in bracket negative x the power of 2, cos, in the bracket, 2x here will become 2 multiply negative x, this one will become negative 2x. So substitute negative 2x in this bracket, this one will become cos of negative 2x. So for the cos, negative here we can ignore. So ignore the negative, so we write back negative x the power of 2, this one will become exponent x the power of 2, cos of 2x. There is no more negative here because we already ignore the negative. So now compare our f negative x here with the original function of fx. So when we compare, as we can see, there is an equal term. Exponent x the power of 2 multiply with the cos 2x. So the conclusion is fx is an even function. So for the exercise 5.1, page 165, this one you can do as your own exercise. If you refer in the textbook, page 164, there is a properties of product function. So these properties can be used in order to determine types of the function. For example, if you want to solve a function that is multiplied with another function, which is x square multiplied with the sine 3x. So in order to solve the question by using these properties, you have to remember all of these properties. So there is no problem if you want to determine types of the function by using the properties or by using the method that I have discussed before this.